One second.
Yes. Shweta went, I think so. She's there on the list. I'll ask someone else. Vimal Rajan, are you there? Vimal Rajan. Vishal? Yashwant? Yashwant, are you there?
Sir,
Yeah,
Sir.
Yeah,
Yes, sir.
Vishal and Yashwant. Yeah. Both of them. For Vishal, I will ask one question, and Yashwant, I will ask one question. Okay. One question you
Okay,
can
sir.
tell. This is for Vishal. And Vishal, can you tell what is the law LAS?
Logical address space, sir.
Okay. What does it mean? What is meant by LAS? You told the abbreviation, and what is meant by abbreviation? Describe it.
Sir, basically it deals with the processor, that is with the
Okay.
number of pages or things.
Okay.
Logical address space consists of two parts. One is
Okay.
page number and page offset.
Okay. Okay. To overall, what it represents? It represents the size of the process.
Causes.
Process. Okay. Fine. Thank you. And Yashwant.
Yes, sir.
And what is a physical address space?
Uh,
It represents the size of the memory. Address space. In the name itself, the meaning is there. Physical address
yes, sir.
space.
Memory address. Yes.
Yeah. Memory address. Okay. And
Yes.
what is the other bit? How to say? What is the bitwise representation of this PAS?
Uh,
Bitwise
bitwise.
representation means it is nothing but you're going to locate a bit inside this address space. So what does it is how it is termed as? What does it mean?
Uh, yes,
It is physical address. Okay.
yes, sir.
For example, imagine your place. From where you are coming, Yashwant? From what is your name? What is the name of the place?
Tambram, sir. East Tambram.
East Tambram. Okay. If East Tambram is a very big location, that is a physical address space. Okay.
Okay,
And
sir.
Yashwant house is a physical address locating a bit. Okay.
Okay, sir.
So in that address space, physical address is inside. The physical address is nothing but the number of bits required to address the main memory. So yeah, that will be that bit number of bits will be used to address your exact content. Okay.
Okay, sir.
Okay. Thank you, Ashwant.
Thank you.
And Shiva Balaji, are you there? Shiva Balaji. Shiva Balaji. Sophia.
Yes, sir.
Sophia. Yeah. Sophia, can you tell what is page offset?
Page size, sir.
Offset.
Size of the page.
Okay. And what will, how you will describe it in terms? I will tell you. You told in single line, I will tell. Page offset is nothing but the bits which are used to address the byte within the page. Okay. It is
Okay, sir.
but you're going to match exactly. because page size is separately it will be there, page offset is separate, both are different. Okay, from
Okay, sir.
if you want to calculate the page offset means you need to know the page size, then you can achieve the page offset. Okay,
Okay, sir.
offset will is nothing but which will map the both the address for physical address and logical address. Offset will be same. Using that only you are going to map that. Okay.
Okay, sir.
Okay, if that's fine. And do you have any idea about PTE?
PTE.
Yeah,
No, sir.
that is nothing but page table entry. Okay,
Okay, sir.
where it comes page table entry.
In uh, page table, sir.
It comes inside the page table. Okay, and that entry to what it is representing the entry. Number of entries in the page table is known as the page table entry. Okay,
Okay, sir.
and what is PTS?
PTS. Page table size.
Exactly. And for why we are using this PTE and PTS means for each and every table we have a size. If you are having a process means that entire process will be considered as the physical address space. Okay, and each and
Okay.
every individual page will be there. For that page specific size will be there. Like that only for page table also we will have a certain size, and each and every block will represent a separate table. Okay, table or frame, and for that information some certain size will be available in that page table. For that representation only page table entry and page table sizes are useful. Okay, and yesterday whether you have noted all the formulas and the what are the contents I have wrote in the smart board, have you noted it?
Eh, yes, sir.
I asked you to keep a notepad side by you and asked you to note. It will be helpful. Okay. If
Okay, sir.
if you missed it, also you can collect it from your friends. Okay. Unfortunately, I couldn't give the. I thought of saving the entire presentation as a soft copy. The first half, unfortunately, I lost it. I couldn't recover it. And second half, I have it. I will share it in the Google Classroom. You can refer it. Okay.
Okay, sir.
And it's thank you, Sophia, and it is for all the students. And Thiruvengadam, are you there? Thiruvengadam. Okay, have you recorded the session yesterday? Complete session is do you have it from the morning till the sorry? So if audio is not good, also not a problem, but the content is clearly visible now. Okay, if you see that structure itself, you can understand, right? Okay. Can you please share that content with all your friends? It will be useful for them. And I have content, and it is not a audio, I mean multimedia document, it is a JPEG document. I will also share that so that yesterday's content your friends can have. Make sure that you share with everyone. Okay, if it is possible you can share it in Telegram also. Okay, okay, that's fine. And today we are going to see about file management. And until yesterday, we saw the things which happens behind the screen. It means that memory, paging, page table that happens inside our laptop, which is not visible. And now in this fourth module, we are going to see about the file management, where everything is before our eyes. Okay, we can see everything. What are the files? What are the operations possible in files, for what purpose files are used, everything. Even in our mobile phone we have files, laptop we have files, in everything. And To be short, I want to ask one simple question to you. Okay, what is a file? Okay, I will ask Santosh. Santosh Prasad, are you there? Santosh Prasad. Santosh. Yes, sir. Okay, Santosh, you just replied for the question, what is file? You just write in 2 or 3 words, that is enough. Santosh, are you there? Okay, you just type the answer. I will ask some other person. Satish Kumar, this is space to store documents, image. Okay, fine. That's right. Okay, actually, file is nothing but which stores the documents and images. Some information will be in that. Some information or data will be residing in it. It is for recording purpose. Okay, you can put some data inside it and you can record it. That is a, what is a file system? You know about file. What is a file system? I'll ask someone else. Shruti, are you there? Shruti, two Shruti's names are there. Yes or yes. Anyone can tell. Shruti, Shruti.
Yes, sir.
Yes. Okay, what is meant by file system? You have any idea? It is not technical. You can think and tell simply. What is file system? File means he told that it is which is used to store the data. Okay, that's fine. So, that is correct. Okay, what is file system? Do you have any idea?
It controls the data stored.
Yeah, it is nothing but it controls the data. It controls the data. It seems that how the data is stored and retrieved. Okay, it is a system of doing that per process. Okay, system is nothing but which is used to do one process. Okay, file system. Okay, correct. What is file management? Yeah. Now only we are coming to into the topic itself. Whatever the thing I ask is not a technical question. It is just a general question. You can answer in a general way. You need not think in depth. Okay. What is file management? Can I ask? Shivant. Shivant, are you there? Shivant.
Yes, sir.
Okay, tell what is file management.
A methodology or procedure which enables CPU to manage the file, store it efficiently, and retrieve it. Sir.
Intermediate thing which is used between the user and the system to use that file. Right? Am I right?
Yes, sir.
Okay, it is just the intermediate. So file system, file manager. Okay. Now we can go into the topic. This is it is very common. Everyone knows this. Sometimes you'll be feeling bored of this presentation. Okay, current controlling the file to manage and store. One second, current. Yeah, controlling the file to manage and store the files and managing its integrity. Good. Thank you for the answer, Karan. Okay, I'm going to display the presentation in file management. It's the fourth. It's the fourth module, so you can start the file management. One second. Guys, is the presentation visible? Guys, answer me. Anyone?
Yes, sir. It is visible.
Okay. Visible. Yes. This file management. File management is nothing but a system that consists of system utility programs that runs a privileged applications. Okay. Input to the applications is by means of files, and the output is saved in the file for a long time. Once your file saved, input means you're going to put any information inside your file, and the output means that information is going to reside in your file, okay, for a long time until you delete it. Okay, that is file. And during this process, I have a doubt to ask to you guys. In between this presentation, it is a practical thing. Do you anyone have a pen drive, and have you recovered information from that pen drive? It's a practical question.
Yes, sir.
Okay, and may I know how you recovered it? Sorry. Okay. Yes. So using that software, you did. You have recovered a file. Okay. Yes. That's what exactly I came to. Yeah. Actually, what happens is Thiruvengadam. Yeah. Thiruvengadam, thank you for the answer. I will tell to the students. Okay. What happens is, if the some content is present in your disk or a USB drive, means if you delete that content, it won't be deleted. Okay. Only the index of that content only will be deleted. And one more question, Thiruvengadam. Thiruvengadam, can you come online? Thiruvengadam. Yeah. Hello. Thiruvengadam. Yeah. And can you tell which file you have recovered? Whether you have recovered the file which you lost recently, or you recovered a file before a long time. You lost any file. That file you recovered recently. And why you cannot recover the old ones? Yeah, exactly. Uh, yeah. Okay. Thank you, Thiruvengadam, for your answer. Actually, what happens means, if I am having a USB disk, and I have some content in that USB, and if I want to delete that file, means what happens is the file will not be deleted. The file index number only will be deleted, and it will be shown to us as the folder is empty. Okay, but still the content will be residing inside that disk only, in that USB, I mean pen drive. Okay, and if I want to recover the document, if I delete the file before 2 days or 3 days, and after that I didn't use that pen drive for some other purpose, means I can't recover it, because the invisible data will be inside. By using the some values related content, we can recover the file. But if I use, after deleting one content, if I override that pen drive with some other movies or songs, means that data cannot be recovered. If 4 MB data is there, in that 2 MB I overridden with some other content, means that extra 2 MB will, which is not overridden, only I can recover, but it might be meaningless. Okay, so like that only for files also. If you put one content in your file and if you save in your system, it will be residing in your system for a long time. It cannot be deleted until you override it. Okay, is it clear why I came into this example? Is it clear, guys? So file, once it is returned, it will be for a long time. It cannot be, that is the output. It cannot be deleted. It can be overridden. Everything can be overridden, but it cannot be deleted. We'll go into the presentation. This is a file system properties, long-term existence, shareable between the processes and structure. These are the system properties of the files. Okay. Operations. What are the operations in the files? Okay. These are the operations that user can do directly over the file system. The user can create it, delete it, open the file, close, read, and write. These are all the operations. And who can restrict these operations? Do you have any idea, guys? Anyone, any volunteers who can restrict these operations? Guys, are you there?
Yes, sir.
Who can restrict it? Yeah, tell me the answer. Operating system can restrict the operations. That depends upon the user's privilege. Okay, some files cannot be modified, they can be given as a read only. So what happens is the file manager will give the instruction to the operating system that to protect the file read, there is different types of mode will be available: read only mode, write only mode, like that. It will be useful for the security purpose and protection of the file data. Terms used in the files are field and record. These are the terms used in the file. What is field? Means field is the basic element of data. It's a single value. Characterized by its length and depth. The field value is characterized by the length and the data type. Record. Collection of related fields is called record. For example, before in past, you'll be having a record player, okay, tape recorder. It seems that tape will be recorded and film will be there. It will be continuously related content. After that record only, you'll be delivered a full song or a music, everything. If you cut that film in the middle, means your record will be baked and it won't work. Okay, that is the example for record. And for other example which we can give for the record means, or in your school days, you might maintain the lab record, like that. Record means in that different manuals will be there. In that lab record, different types of experiments you might have been done in that, and you'll be having an index in the front. Okay, so it shows that the entire thing is a continuity and it is recorded. So from the beginning to the end, it is a continue, and it gives meaning. So that is called record, like that. Collection of related fields is called the record and treated as a unit. Employee records, for example, you can take the employee record. What are the terms used with files? Means files for with files, it will be a collection of similar records treated as a single entity, have file names, may restricted access. As I told you, read only read only option only will be given for certain files. Okay. While coming to the database, collection of related data. Okay, that is one of the term. And relationship exists among elements. In database itself, nothing but each and every individual data will be residing or relying on the other one. From the before data, the other will be, it will be a continuity. So only in some databases, if some data breaches happens, means in between we can easily recover or we can duplicate the content easily by using, because that continuity, if it is there, means it will be there. The relationship should be there with first data and the second data. Then it can be easily protected, or if there is any loss, we can easily guess it. What are the typical, the creation, deletion, open, close, are all the normal operations in file? And what are the critical operations in file or files are retrieve all, retrieve one, retrieve next, retrieve previous, insert one, delete one, update one, retrieve. These are the things related to the data. When you lost it, you are going to retrieve. File is nothing but a data, right? Both comes on the same. The file management system, the way a user application may access files. As I asked the question in the beginning, file management. What is file management? Means it will give the it will manage the things that where the user can access the file, store, retrieve, and processing. Those things are provided by the file management system. The way a user of the application may access files. See, if I am using Facebook, means I can access some files inside my account. So that is done by using a file management system. Programmer does not need to develop file management software. So it is not necessary, already it is there. What is the objectives? It has some objectives. What are the objectives of the file management systems? Means meet the data management needs and requirements of the user. Is guarantee the data in the files are valid. Okay, you should guarantee whether the files are valid file or not. Optimize the performance. You should optimize the performance in a way that it should not load for a long time. Okay. Provide IO support for a variety of storage device types. Is minimize or eliminate the potential for lost or destroyed data. We should minimize the lost or destroyed data. We should eliminate it. Okay, and provide a standardized set of IO interface routine. It should be the IO interface should be easy to access the file. Okay, if it is tough, the file accessing will be complicated and the user feedback will be less and the number of users will be reduced. Okay, provide IO support for multiple users. For it should be provided. See, if the access is very less, means that system cannot be used efficiently. If the access is improved, everyone can use that access. Means it can be improved. It should be open to all. It should be open for multiple users. What is the minimal set of requirements? Each user should be able to create daily. These are the this minimal set of requirements. What does it mean? Means it should be applicable for everyone, and what all the operations should be done in the file. So only that file will be an efficient file. Otherwise, it will not be efficient. Some data set is there which is a name meaningless, and it cannot be used by everyone. It can be used by the machine code which understand that specific table rows and columns, fields, and numbers, which understand that only some codes will be accessing that data set. So the file should not be like a meaningless data set. Here said it should be a user friendly. Okay, what is for that use? Making it to user friendly. What types of requirements are necessary? Minimal requirements. It is not the maximum. Minimum it should be there. If it is there, means it will be useful for the users. Okay. In that way, the first one is each user should be able to create, delete, read, write, and modify the files. Each user may have controlled access to the other users' files. Okay. And the user may control what type of access are allowed to the user's files. So you should have the control over the controls also, user control. So each user should be able to restrict the user files in a form appropriate to the problem. See, if I am having a problem, if someone is accessing such important type of file, means my system will be in a trouble. So at that case, I should protect that file by putting a shield over it. So that requirement should be given satisfied to the user. Each user should be able to move data between files. Okay. Having two nowadays you can do it easily. If you are having a movie in A folder, and if you need to change it to the B folder, which is available in the different drive, means you can easily select send to option and you can click it. If you connect the USB also, you can easily drag and drop the file inside it. Okay, so it is very easy from the user point of view, but behind it has some effort, some technical thing is happening. Okay. Each user should be able to back up and recover the user's file in case of damage. In this only, the case which I discussed with Thiruvengadam, he told that he used the recover software to recover the data from the pendrive and he recovered it. And that sort of facility should be provided for the user. So for that recover software, he used and recovered the data from the file, but the data recovery, if it is defaultly available in your system, means it will be highly useful. So that should be implemented by the operating system providers. Okay, and each user should be able to access the user's file by using the symbolic names. This is the file system software architecture. So here the base of the file system software. Each and every operating system will be having a file system software. So what is the structure of that means? Here it is. Disk driver, disk and tape driver, disk device driver and tape device driver. It's a disk and tape. Both are drivers only. It is a memory driver. Okay. After that, basic file system, and the uppermost one is basic IO supervisor. First is the file system, second is the IO supervisor, and logical IO. Okay, and the file sequence, indexed and hashed. A hashed is name which is used for protecting the files, and after one beyond this only, we'll be going for the user program. Okay, and these explanations are as follows provided in the upcoming stripes. Device drivers. What is a low device driver should be a lowest cost, communicates directly with the peripheral devices, and it should be responsible for starting IO operations on devices and processes the completion of an IO operation. So specifically IO in this file system, why we are going to use the IO operations means the operations only going to be performed over a file. File is nothing but a record or a data holder in which we are going to put and take the data. So that is nothing but the IO operations, input and output operations. Now, no process will be happen inside the file. The process will be happen in the software code or compiler. Anything such kind of things only is necessary. But in file, only the IO operations can be performed. That IO operations is nothing but storing the data, retrieving the data, and maintaining the content inside the file for a long time, updating it, deleting it, like this type of operation in the IO operations. If you have anything in your file, if you're you're opening your system, selecting a content, deleting means there the IO operation happens. How it happens means opening the file is a IO input IO operation. Or input is nothing but selecting it. Delete is the command given to us. Once it is deleted, the file is shown empty to the user. That is the output for the user. Okay, like this only it happens. Basic file system is a physical IO, deals with the exchanging block of data, concerned with the placement of blocks, concerned with the buffer blocks in the main memory. Like this, this presentation goes in depth. I will upload this presentation. It's complete theoretical. Okay, you can take a look on it. It gives some information to you regarding the what are the things happening behind the screen of the system. To be short, I will explain the important diagrams in this. Is it okay if you want to present me? If you want me to present the entire theory, also I can do it, guys. Guys, are you there? Anyone respond? Sorry. Hello.
Yes, sir.
Okay, I will explain the important things and I will move on to the next topic. Okay, and you can refer this slide. It is very easy and understandable slide. You can refer this, and it will be providing the information directly. Okay, there will not be any complications. Okay, is it fine?
Okay, sir. Okay.
Okay, that's fine. And here you are seeing the elements of the file management. What are the elements? First of all, we can split the elements of the file management here into two. One is the file management concern and the another one is the operating system concern. Now we are going to see only the file management concern and what happens behind it. The things which are happening behind it we saw in the third module. Okay, and we are going to see the fourth module in the file management concerns only. Here, what is happening means the user and the program comments are there, so it will be the given as an input. So before that, what we'll be having means we'll be having a directory management and the user access control operation files. This will be given as the input, and it will fall as a file structure. Okay, file structure will become access, what type of access method is given, and file manipulation functions. Okay, so after that it will be stored as a record. These records will be now small blocks. Okay, this in this side the file management concern is over. So afterwards how the file is stored inside your free storage memory means it will be passed in blocks, block by blocks. Okay, physical block in the memory. See, like this record will be of different records. It will be a continuous record. A continuous means there will be some related information to track your file. Nothing but time, date. These are all the related information. You can easily recover your file based on that time. Okay, like that a record will be maintained. Record is maintained and it will be passed as a block. It will be given to the physical block in a memory buffer. So it will do some process and disk scheduling. See, when your data is going to be stored in a secondary memory, there should be a scheduling process happen. If you put directly and take it outside means it is not that much secure. Okay, the files should be allocated and disk scheduling should be happened over the IO operations, and then only it will be stored in the physical block of the secondary memory. First it will go to the main memory. So here what happens means in this secondary memory the files will be residing for a long time. Okay, if you want to access any files means you will be use the main memory buffer. So for easy access, the what all the frequently used or currently using files will be taken from the secondary memory and stored in the physical memory, and you can use it directly so that the speed access will be there. But here the if you're doing everything over the hard disk, it will not be that much faster. It will be taking more time to access a file. Guys, is it clear?
Yes, sir.
Criteria for file organization to be shortest access time, escape, or ease of update. These things you can see. Okay, guys, I will move on to the next presentation, and we can close this as follows. This is the overall structure of the file management, file organization, like this. Okay. This is just the general introduction for the file. Inside that, what we are going to see is files and data. The main thing is RAID. I'm going to take the RAID concept. Do you have any idea about the RAID concept, guys? I'll ask someone. Shivant, do you know what is RAID?
Sir, I have an glimpse of an idea, sir. In
Sir?
a previous example, during recovery, you said, right, sir, it will remove so that a part of data copy, like stats and replica stats, will be present.
Okay.
So that if one part of the hard disk fails, means a copy of it will be present in another part, which we can read.
Yes. Yes. Yeah, that is right. Okay, that is correct. Exactly. In this place, RAID means it is used to improve the performance as well as the redundancy of the data. Okay. So what you have done in that hard disk, like in a real-time example, what you told means you have other copy in other hard disk, and if in case of any failure, you can access it. So what happens in that place? Sure, if you are using two hard disks, one is for backup and one is for your original access, and what happens in that place? Can you tell? What are the things can happen?
Um, Sir, there is a single disadvantage because we are not using the entire memory. Only the
Okay.
half of the memory only we can able to use. But the data can be saved because if one a hard disk fails means other hard disk can be used as a backup.
Okay, in this place, what happens means your cost is improved, right? See, my utilization is 500 MB. Okay, but I am using that other 500 MB for my extra backup. When it is small amount of data, your cost will be saved. And when it comes to big amount of data, what happens? If you want to use 1 TB, if you want to use 1 TB of processor in a 1 TB memory means, what you need to do is you need to invest for 2 TB, but the utilization rate is only for 50%. Can you understand, Shivan, this scenario?
Yes, sir.
So the cost is doubled. Okay, and Thiruvenkaram has sent some message. The read speed is doubled. Okay, and the thing is, while read speed, I think. Thiruvenkaram, the read speed is not doubled. Okay, if a two disk is there, if I'm going to put my copy of two. Thiruvenkaram, can you come online? Yes, I will tell you. Okay, if you are having two disks, okay, imagine it as a two disk. Okay, I'm going to put a same data in a two disk. That is, I'm going to write it. Okay? While reading, I'm going to read it from one disk only. The other disk will be idle. So here the read speed is not doubled, but the writing speed is reduced because I need to write the data in the both the disk also. So here for writing it will take more time, and for reading it will take less time. Is it clear? Okay. Yeah, exactly. Simultaneous. Okay. Okay. Actually, what concept is followed in RAID 1 is data mirroring, right? Okay. And the drawback of the RAID 1 is double storage cost. Do you agree that double storage cost? Okay. And high reliability with fast recovery. Recovery speed is increased. Okay, but no. So speed is increased while recovering.
Sir, I
But
have a doubt.
but while mirroring, you are going to mirror the entire content to the other. So while writing, just imagine the scenario that you're going to write the same content in two notebook. You will take a huge time now. So you're going to mirror the content. For writing, the time will be increased. For reading, it will be easy. And recovery time also it will be easy for recovering. Immediately you can recover. If one system fail, immediately you can recover the 100% data from the other system. Okay, is it clear now? Okay, Shivant, now Thiruvenkatam, thank you, and Shivant, now you can speak.
Sir, is it the concept of threading, sir?
Sorry.
Threading. When a file is created, it will have a thread and a replica thread of it will be stored in some other node in a cluster like that. So,
That is mirroring, right?
mm, because in recently I had a study on Elasticsearch. In that we use the concept of shredding to store a copy of the file, sir. If there are yeah, one of the cluster fails means a copy of that will be stored in another cluster.
Yeah, that happens here in this disk. And before that, Shivant, let me show the presentation and I will complete the presentation. The concept which you are telling will be available in that presentation. So let others also know, because before starting this session, if we go in depth inside means other students will cannot understand anything. Okay, can I start the session?
Yes, sir. Thank you, sir.
Yeah. Okay, RAID. Before coming to RAID, I would like to tell what is the abbreviation of the RAID. RAID is nothing but the redundant array of independent data or redundant array of inexpensive data. Okay, is it clear? It has the two abbreviations. Both the abbreviations are correct. Independent or inexpensive. Okay. RAID is nothing but RAID is a data storage visualization technique. It is a visualization technique that combines the multiple physical disk drives components into one or more logical units for the purpose of providing the data redundancy and performance improvement. Okay, and while coming to the right, what will be the previous version? So here multiple disks, physical disks, are utilized for improving the performance and data recovery speed. So what see, for each and every system will be there will be a previous system. Okay, because of that failure only this system will be emerging. So what is the name of that system is single large expensive disk. Okay, it is nothing but a single disk. It is very large enough and it is highly expensive. If the data lost, everything is lost. If that system is damaged, our business will be at risk. So like that type of system was there, and after that only this RAID, redundant array of independent disk, arises. Okay, so first of all you have to be sure about whether your data is safe, or when it lost what will be your problem. Okay, so further we need to ask some questions. Okay, do we have a backups of all our data? So if that stuff is not there, we cannot afford to lose. I mean, if data is lost, we will be in a risk. Okay, and second one is how often do we have a backup? Okay, backup means daily, weekly, or monthly. Nowadays, you are having a WhatsApp backup is there. Okay, daily, weekly, or monthly. Okay, while coming to the business, each and every day the process will be increased and data will be increasing. So that update should be done on the backup also. See, main memory, obviously the mm, content will be updated then and there. If I'm working on the system means each and every seconds the data is being stored in the main memory. Okay, well, backup each and every daily or weekly or monthly some backup should be there. If that backup is there means if we lost some data also we can recover it. Okay, and whether that backup is a magnetic, optical, or physical, we should consider that. Okay, but backup has some capacity. It's something of hardware related thing. We should be sure about that. Okay? And how long would it take to total recovery for them from the disaster? If the disaster occurs in the server, for example, in we can take the HCL software company, and one of my colleagues worked there, and immediately the server room caught with a fire. Okay, the server room is burning, and the other network admins were sitting, so they cannot stop the system. Okay, and the data which are all holded in that server is now at risk. Okay, and the network admin was very cool, and he's one of the known person who worked in the HCL, and now he's in Noida. Okay, and he was very cool. Okay. Uh, and my friends, this was the scenario told to me by my friend. Okay, and he was very cool at that time. And they asked why you are cool. Your entire system crashed and data is lost. You are going to be in a trouble like that he told, okay. And he told for each and every half an hour we have a backup facility in other part of the geographical location. It seems that it is not inside the office. That backup server is located in different location. If it is Chennai means in Pune the backup will be there. Okay, for each and every half an hour that backup data will be stored in other office. Okay, then what happens means within 1 hour time the entire data which are residing which were working inside that server which is burned is recovered immediately after 1 hour by that system network admin. Okay. So backup will be useful in that way. So the frequent time backup will be helpful for us in when great disasters occurs, and immediately if that 1 hour backup is taken means immediately the others can work by using those backup data in their company. So here great loss is restricted and the client loss is restricted. Okay, if money we are losing means we can change it. If that server is damaged means we can change that server. If the client is not happy with us means we cannot go and search for a good client who we are holding for a long time, because that loss will be affecting the client's business also. Okay, so recovery is that much important. Of this presentation is nothing but storage advantage, disadvantage, increasing reliability via redundancy, and RAID mirroring and data striping, and RAID levels. Secondary storage. What is the secondary storage? It's primary storage is nothing but which is RAM, which will be accessing provided for the fast access. And secondary storage is the hard disk, and this complete thing happens in hard disk area. Okay, hard disk area. It seems that in data server or data warehouse, huge number of hard disk will be residing, and the process which happens in that place is secondary storage devices. Everything is hard disk related. Significant role in storing large amount of data as main memory is expensive. Okay. Everything in the main memory is highly expensive. Plays a vital role when disk is used as a virtual memory. So when that expensiveness is reduced means when the concept of virtual memory is used, that storage of data expense will be has been reduced. Okay, and everything is magnetic in nature. Magnetic in nature means nothing but a hard disk related. And characteristically uses a moving head disk mechanism to read and write data. For example, have you seen the gramophone, guys? Respond. Gramophone. In that gramophone, to read the data, to read the song inside gramophone disc, you'll be having one needle. Okay, that needle will be moving over the gramophone disc, and the disc will be rotating. So like that type only from the initial until now, if you saw the uh, um, disk driver in your laptop or the system means when you inserted the disk, your CD or your DVD will be rotating, and that speed you can sound and speed you can analyze, and that will be monitored. But inside the disk, you can see the small glass-like one particle. It will be reading the data and writing the data. Okay. It is nothing but a moving head disk. And, it will be read up and down for reading and writing the data. That's what is given here, and everything is a physical here. Secondary memory. Yeah, RAID. Well, coming to the RAID, redundant array of inexpensive data or inexpensive disk or independent disk. So, for what it emerged, RAID from the previous large memory. Why we came into the RAID means performance limitation of disk to overcome the performance limitation of a disk. Okay, what are the performance limited means the performance of a single disk is very limited. Okay, for a single disk means it has specific capacity, and for that capacity it will have some characteristics to do some work. Okay, the throughput, so for example, throughput is 125 requests per second. It is the throughput. The throughput is nothing but the work done in a specific time. Okay, if I'm giving the request means it will go to the system and complete, and it out will be given to me. That is the throughput. Okay, and the bandwidth, the maximum bandwidth will be, bandwidth speed will be 20 to 200 megabytes per second, and this sustained, I mean, so it can at least the connectivity can be maintained at 15 to 30 megabytes per second. It's very difficult to significantly improve the performance of that disk. Okay, disk or electromagnetic device. So increasing the device, it's something called hardware related. So how to improve that? That has been improved by using the RAID concept. Okay, the speed gap between the disk and the CPU is widening. What is the speed gap? The processor speed, if the disk and processor are of same speed means, okay, that's fine, the system will be performing high. But the central processing unit speed is 60% increasing per year, and the disk speed is increasing 10 to 15% per year. So it is somewhat, it's not somewhat, this is highly less. It is more lesser than the CPU. Okay, improvement in this technology is very impressive, but only the capacity and cost are right. Okay, if you, as I told you yesterday, if you are in yesterday, and we discussed about the paging concept, we had a conversation on improving the memory. Okay, but while improving the memory, it is very intelligent work. Okay, if memory is high, my system will be smart. I can do a lot of works and multiple operations can be done. I can put some high configured chip in my system. All the works you can do, but coming to the cost, it will be high. Capacity, if your memory capacity is high, other things should be supporting your memory. So simply, if you are having huge memory with less capacity of your systems, it is useless. Okay, cost and capacity should be concerned. And this is the history. What does RAID stand for? Is a redundant inexpensive disk, and it was introduced by Patterson in an article. The published paper described the various type of disk array and referred to as the RAID. The disk array, its main is disk array. What is the meaning? Okay, while going in depth inside this topic, what is disk array? Disk will be placed in array. Array means continuously. A disk array, and we are going to use that disk in different way. Okay, that is disk array. The main RAID is nothing but the disk array utilized by for different purpose in different ways. Okay, the basic idea of the RAID was to combine the multiple and small inexpensive disk drive into an array of disk, which yields performance exceeding a single and large expensive. This is the previous version of the RAID. Okay, I told you, na, single large expensive drive. This was the one, because only one single and large drive will be there. User or multiple user should store their data in that one, and they should retrieve the data. If failure occurs, entire system will be damaged. So like that type of dropbox were there. And additionally, this array of drivers appears to the computer as a single logical storage unit. Okay, in RAID you may have multiple number of disks, and you can have many backups. Your data will be saved in different disks, and it can be scattered. Anything happen in the RAID, but logically for the user it will be looking as this, so only single storage. Okay, it will be appearing for you as a single. If you are putting, for example, if you are using a cloud service, means you are putting your data in the cloud. What happens means that data will not reside in a single location. Your data will be converted, and it will be splitted into related content, and it will be scattered among different virtual machines. If you want to recover that based on the related keywords, your data will be recovered and displayed to you. Okay, so it is not going to store in a single place. An improvement of reliability via redundancy. How it happens? Okay, in SLED, reliability becomes a big problem. The data in an entire disk may be lost. So as I told you, it will be in one disk only, it may be lost. as the number of disks per component increases, the probability of failure also increases. Uh, if I am how to say the if I am having a data in one disk, there is a lot of probability of failure is there. So it may lose. Okay, if I am having in many disks, okay. So if it loses, I can recover it. If I may have a disk related content in some other two disks. So if one disk is lost, I can recover it from other disk. That's what is said here. And suppose a reliable disk fails every 1 lakh hours. Okay, you can consider for every one disk fail for every 1,000 hours. We need to measure for how many days that disk failure might happen. Okay, the reliability of the disk in an NRA is equal to reliability of one disk by n. Here, the after performing this calculation, this is guessing. So for everything the failure guess will be there. Okay, for if your password means if you are having 4-digit password and if you put the password checker means it will check and tell in this many years your password will be cracked, like that some probability will be given. So for that, for disk failure rate will be 41.66 days it can fail in every 41.66 days. So what is the solution for it means redundancy. What is redundancy? Copy of data. I think this redundancy is the mirroring and data striping. What is mirroring? So mirroring means you're just taking the copy of the data in the other set of devices. So that's what I here explained. Duplicate every disk. That is called mirroring. Logical disk contents of two physical disk uh, consists of logical disk consists of two physical disks. It will have two physical disks. Every write is carried out on both disks. Okay, as we discussed before, every write is carried on both disks. If one of the disk fails, the data read from the other. Okay, data permanently lost only if the second disk fails before the first fail is replaced. So here the problem is there. Okay, if I am having two disks, one disk failed. Okay, so I can take the content from the second disk, so I am the safe side. Okay. And one disk failed, I'm going to recover it from the second disk. At that moment even that second disk also failed. So here the process is 100% risk. So in this case 2, the mirroring fails. Okay, so it doesn't mean that mirroring is a failure concept. Okay? Mirroring is also have a drawback. Each and every system have a drawback. I'm telling that drawback. Reliability in mirroring. Okay, suppose mean time of repairing of tens. Okay, here also the calculation comes here. Okay, if 1 lakh failure rate is there, and here the repair time is fixed to 100 hours. I'm having two disks. Okay, so the mean time of the data loss of the mirror disk system is given as 10 power 2 by 2 into 10. Why 2 into 10 is given means the repair time of each and every disk is considered here as a 10 hours. Okay, if one fails 10 hours and the other fails, that also 10 hours. And the 1 lakh time square means I am having two disks. Okay, 1 lakh square. So by applying this redundancy, I mean mirroring concept, here the recovery rate will be the mean time of the data loss will be increased to 57 years. Okay, here the mean time is 41 days of failure probabilities here. Here the mean time of the mirror data loss can be happen after 57 years only. This is the rough calculation, not the exact calculation. Okay, because here the symbol is given rough. This is if it is mentioned here means it is a rough calculation. What is the main disadvantage of the mirroring is it is more expensive approach because you're going to buy two disks. Okay, and parallel disk system. Okay, for the overcoming the disadvantage of this mirroring, the concept arisen is parallel disk. We cannot improve the disk performance significantly as a single drive, but many applications requires high performance storage system. So what will be the solution for that is parallel disk solution, higher reliability and higher data transfer rate here. So okay, how the reliability is improved means I am having 4 disks and the data are stored in each and every disk in a serialized manner. Okay. For example, in one disk, 4 slots are there. Means before we are storing means in that 4 slots, I will save 4 data. Okay, 1, 2, 3 in one side, and second disk 3, 4, 5, 6 in the second disk, and the 6, 7, 8, 9 in the third disk. Like that, I will save. But here, what it happens means the first data in the first, second in the second, third in the third, and fourth, and again 5 will come to the first data, first disk, and 6 in the second disk, and third in the seventh in the third, and eighth in the fourth disk. Like that, it will be saved. In this is called as the parallel disk system. It will improve the higher reliability and data transfer rate. And data striping. What is data striping? It is the fundamental of the RAID. Okay, a method of concatenating the multiple drivers into one logical storage unit. That is called striping. Striping the bits of each bytes across multiple data. It is nothing but a bit level striping. So in this, both the things, if it is done for bit level, it is bit level striping. It is a byte level. It will be named as a byte level, block level. Sorry, block level striping. For example, an array of 8 disks writes a bit I of each byte to disk 1. Is it clear? If it is not clear, while coming to the diagram, it will be clear. Okay, sectors are 8 times than the normal size. So, sectors are 8 times means 8 subdivisions will be there. Okay, 8 disk will be there. 8 sector means 8 disk will be there. 8 times the access rate. Access rate also improved by 8 times. And similarly, for block of files, and block level striping is happen. See here, this is the logical to physical data mapping for striping. For see in logical how the data flows means physical means this is the data stored in the main secondary memory, and this is the data stored in the process. Okay, for example, logical means it is a process. This is the physical. See, the data will be in a serialized manner. Okay, stripe 0, 1, 2, 3, 4, 5, 6, 7 to 15 is there. So this data will be splitted into different blocks. Okay, stripe 0, stripe 1, stripe 2, stripe 3, 4, 5, 6, 7, 8, 9, 10. Like this, it will be splitted, and this is called as the striping. Okay, each and every stripe we see if 1, 5, 9, 13 is lost, if one disk is failed, I can recover by guessing that what content will be in the stripe 2, because stripe 0 is missing, 0 is there, 2 is there. So in between what was there, this stripe 1 is there. So I can recover it. So physical recovery of data from this disk damage is recovered by using the striping. This is one of the striping is one of the smart technique. RAID levels. Data are distributed across the array of different disks. Okay, array of different, that is called RAID. Okay, redundant disk capacity is used as the parity information used to store the redundant disk capacity. It seems that one parity information means if you are having your disk stripe 0, stripe 1, stripe 2, stripe 3 is there. I'm going to introduce another one stripe, that is the thing but the parity stripe. Okay, this parity stripe consists of the key parameters of the information which is available in the stripe 1, stripe 2, stripe 3, and stripe 0. Okay, this will be useful during the recovery process. So what happens means this parity information which guarantees the data recoverability in case of disk failure. Okay, because it will be having some key, using that it can be recovered. And levels they decided according to the schemes to provide redundant redundancy at lower cost by using the striping and parity bits, different cost performance trade-offs. And I will show you the image for levels will be coming here. In this, the parity we'll be seeing the parity and how it is used. Okay, for RAID 0, why RAID 0 is nothing but, as it told, it is the data stripping process, stripping at the level of the blocks, data split across in the drives and resulting in higher data throughput value. It's split across. The data can be recovered immediately. Okay. Performance is very good, but the failure of any disk in the array result in the data loss. RAID 0 commonly referred to as the striping. In this, reliability problem is there because of no mirroring and no parity bits. This is the image of the RAID 0. This is the RAID 1. Okay. Introduce redundancy through mirroring. We use the mirroring. How the redundancy is improved means by using the mirroring concept. Expensive. It is highly expensive because we are using the if 4 disk we are having means we need to invest for 8 disks. So because we need to take a copy of the 4 disk to other 4 disk. Okay. Performance issues. No data loss is either no data loss if either driver fails. Okay. In the obviously one driver saying it is mirrored, anything can be recovered from the other part. Okay, good read performance, we can read it easily. Reasonable write performance, obviously reasonable write performance means it will take some time. It is reasonable means for security purpose we need to do that write process, it takes some time. So that is here is it is mentioned as the reasonable. Cost and cost per megabyte is high and commonly referred to as the mirror, that is RAID. And RAID 1 mirror, how it is mirrored. This is the actual image of the mirror. See here, stripe 1, 2, 3, 4. It is the serialized striping happens, and the striping RAID 0 is mirrored. The same thing will be here. If this disk fail, I can recover it from here. If one of my stripe 13 is failed, I can recover from here stripe 13. So like that, it can be recovered. RAID 2, using hamming or any other error correction code is used. Here the error correction code is introduced, nothing but intended for use in drivers which do not have built-in error detection. Central idea is if one of the disk fails, the remaining bits of the bytes and associated error correction bits can be used to reconstruct the data. Not very popular. RAID 2 is so before I tell you this about these RAIDs, I will let you know which are all the failure concepts. Okay, actually RAID 0, RAID 1, RAID 2, RAID 3, 4, 5, 6 are there, and 2, 3, 4 are failure methodologies which are not in use, and the things which are used in collaborating with other things are RAID 0, RAID 1, RAID 5, RAID 6, and RAID 10. Okay, here in this types of RAID 2 model, it has a error correction code which will correct the error by itself. Okay, but it is not very popular. This is RAID 3. It is also a very failure model. So improves up to RAID 2, known as the bit interleaved parity. So bit interleaved parity. What happens is in this the data will be here. You can see the B0, B1, B2, B2. Sorry, yeah, the number is wrong. Okay, and PB is there. Here PB is the parity. Okay, the entire information of the data residing in all the slides, keywords will be available in the parity. Okay, disk controller can detect whether a sector has been read correctly, and storage overhead is reduced. Only one parity disk is there. Okay, for parity separate storage overhead is not provided. Only parity disk, individual parity disk is provided for keeping the keywords of the disk. Okay, expenses of computing and writing parity. So for each and everything, you need to take whatever the process comes here, that parity should be here. Data comes here, the parity should be updated. This expense, work updation should be keep on monitored. Need to include a dedicated parity hardware. For this processing, you need to have a separate hardware for performing this process. That RAID 3, it comes under the failure model. Okay, and RAID 4, it also the third failure model in the RAID. the stripes data at a block level across several drives with parity stored on one drive. It is a block interleaved allows recovery from the failure of any of the disk. So from any of the disk, you can take the failure. So what happens here is you can see the image here, different blocks are there, and separate parity disk is there. The performance is very good, but what happens is if this parity itself fails, what happens? We cannot do anything. If this parity, which the entire parity will be lost and all the data will be in a problem. Writes require that parity data be updated each time. It should be updated. Slow, small random writes, but large writes are fairly fast. What happens means for each and every small operations, the performance will be less. And if it is very big, that will be copied immediately. That's what I told you. And if this disk is damaged, the entire system will be at risk. If this lost means you can recover it from here. See, P0, 1, 2, 3, this parity is stored here. And 4, 5, 6, 7 parity is stored in 4 to 6. This entire line parity is stored here. If anyone is failed means from this parity we can recover it. If this parity itself failed, from there we can recover. We cannot recover. So it is a problem. And RAID 5. RAID 5 is the successful one. It is a block interrupt. And if you see accurately, the bit interleaved parity is a failure. Block interleaved parity, which is located in a single place, is a failure. Okay, in 4, block interleaved parity in single place is a failure. Here also block bit interleaved parity, it is located in a single place, it is a failure. And here also here it is completely different. Here instead of parity, error correction code is introduced. So that is the different. But 3 and 4, the parity located in single disk is failure. And in RAID 5, the parity is distributed. That is the main thing. Here, block interleaved distributed parity is there. See here, the parity is P16 to 19. It is located here. See, P16, 17, 18, 19 is here. And for this 12, 13, 14, 15, the parity will be in here, the second disk. And this line, the parity is 8, 9, 10, 11, the parity is here. So instead of putting a separate disk, the parities are splitted and added in each and every disk. So it became successful after 3 failures. Okay, after RAID 3, 4, 5 failures. Sorry, not 5. RAID after the failure of 2, 3, and 4, the 5th is the failure. Spread the data and parity among all n+1 disks rather than storing data in n disk and parity in one disk. This scenario has happened in RAID 3 and 4. Okay, avoids potential overuse of single parity disk. For that, you need not to put a separate server. Okay, improves the override of the RAID 4. Most common parity RAID system. This is used commonly. This parity RAID system is used commonly by others. Okay, what is P and Q redundancy? In this, we will be having a dual redundancy. 2 type of parity. See, if one parity is there, means and another backup Q is the type of parity it will have, and P will be having one type of parity, and Q will be having the one type of parity. Even though P fails, Q will give the data which is lost in the parity. If the parity itself is get lost, means that parity will be stored in some other place. Okay, see here, for example, the blocks are clearly visible to you. These are the information, and these are P is the set of parity information holder, and Q is the set of parity information holder. Okay, let us see from the last one. If the parity 0 to 3 is lost, you can even recover the entire disk data by using the parity available in the here for 5th disk. Here the parity is there. Okay, see, and if the P value here, the parity P12 is lost, so you can take the parity from the Q. It is also a parity. This disk holds 2 parity. Okay, like that. By doubling the security is doubled. Okay, and we have the hybrid level RAID. That is nothing but R10. Okay, R10 is nothing but the RAID type, which is the combination of RAID 0 and 1 in different way. It is commonly represented as the hybrid level. So in this, the first you can see RAID 0 plus 1 within a single disk. It is nothing but you're going to add the RAID 0 with 1. RAID 0, what is the RAID 0? As we saw before, this is RAID 0. What happened is in RAID 0, um, striping process happens. Striping is nothing but splitting up the data. Here the data is splitted up. So this is the RAID 0 and plus 1. Plus 1 is nothing but the concept of mirroring. I'm just mirroring the entire striped data into another stripe. So here it happens, and here if this stripe is failed, I can recover it from here. Okay, this is RAID 0 plus 1. And what is RAID 1 plus 0 means? I am going to add the RAID 0 to 1. So already I am having a mirrored data. I'm going to establish the stripe among them. That is the only thing, because already I have a mirrored data. I'm going to put stripe. I mean, I'm going to split the data among them equally. That is RAID RAID 1 plus 0. Here, if data same type only, if here the data is lost, it can be recovered from the mirrored process. This is the advantage of the RAID 10. Okay, advantages: high fault tolerance, high data availability, very good read and write performance. Disadvantages are very expensive because huge number of data is used. Applications where high performance and redundancy are critical. Okay, and what are the use in real? We need to know where are the rate levels selectively used. That is very much important. We have different types of rates, and it depending upon the property of each and every level. Some companies will see, if I'm having some company, only the data speed is enough, means I have only the high performance enough. I don't care about the data loss, means I can go for the RAID 0. Like that, for each and depending upon the importance and the requirement of the company, the data can be processed. Okay, RAID levels can be used and the data can be processed over that RAID. Okay, we can see that. Okay, for RAID 0, selecting criteria will be, if you want the high performance applications where data loss is not critical, you can use RAID 0. Okay, and RAID 1 means high reliability with fast recovery. If you want a process of high reliability and fast recovery, means you can go for RAID 1. And RAID 10 and 1, both performance reliability are important. You can use, if you in the case of performance and reliability, if you are giving high importance, means you can go for RAID 10 or 0 in small databases. For example, they have mentioned. Okay, and RAID 5 preferred for storing large volume of data. If you are going to store large volume of data, means you can go for RAID 5. And RAID 6 not supported currently by many RAID implementers. So what is the RAID means? Striped mirroring, that is called RAID 6. Sorry, not striped mirroring, dual parity. As I told you, dual parity means we are having a P plus Q parity. That is called dual parity. It is not supported by many nowadays. Okay, and this is a reference, and with this this RAID presentation is over. Guys, until now, is this clear? You get a complete theoretical only, and no way you should know about this. Is it clear, guys?
Yes, sir. Yes, sir.
Okay, and yeah, Thiruvengadam, tell. Yeah. You can use the RAID concept with whatever combination you want. You can do it. That is independent. Okay, even if you want to introduce the different types of infrastructure for your own company, means you can create your own RAID itself by using this disk array concept. No one is going to stop you, and it will not be standard, because you are going to face the scenario or face the problem which you are constructing. See, if I am going to construct a building in my own decision. I'm putting my money. I'm going to construct some stuff in my place. I'm responsible for that. I will face that difficulties. Okay, that depends over me. Like that only this RAID concept. Okay, you can use it in different way in based on your convenience. And who knows, it may be a profitable thing other than that. Okay, and for that also I have an examples for you. Recently I have collected some non-standard rates. Now you have seen the standard rates, rate 0, rate 1, 2, 3. The failed models also standard only, and 4, 5, 6, and 1001 are also standard only. Now I'm going to display you the 4 non-standard rates that which are currently used and successfully they are using in their company. So that will be useful, and you can also design your RAID, and this RAID is not for the system purpose. Okay, in the past time only they used RAID in the system, and nowadays they are using the data centers for virtual machines in the data warehouse. It will be the RAID concept will be used. Okay, but nowadays it is only in data centers only, not in the user point of view. If you want to design it and go, if you go for a big company data warehouse or data centers you are working in, you can use this. I will show you some non-standard rates. Those rates are old one. This is the new one, but no standard is published. And in this rates, the scenario which you asked comes here. Okay, because different levels can be used in different fields. Many configurations or other than the basic numbered rates levels are possible, and many companies, organizations, and groups have created their own non-standard configurations in many cases designed to meet their specialization. Each and every company will be having a specialized need. Okay, if Google is having means no other company will have the same type of infrastructure. Google only will have that type of infrastructure, and they may go for new type of building the data centers for improving the performance. They can try with the new ones. For that, they whatever the thing they want, they can do it. They are independent. Okay, and the list of the non-standard rates are Linux MD RAID 10, Hadoop, DGFS, declustered RAID. These are the 4 things. And this is Linux MD. What happens here is, Linux MD RAID 10 provides a general RAID drivers that in its nearer layout default. Okay, defaults. Here two layouts are there. One is nearer layout and the far layout. For 2 things, they have followed the 2 different RAID methodology. Okay. Defaults to a standard RAID 1 in RAID 1 with 2 drivers, and standard RAID 1 plus 2 with 4 drivers. Okay. However, it can include any number of drivers. Sorry, any number of drives, including odd numbers. Okay. And the second thing is within far layout. With its far layout, RAID MD RAID 10 can be run with both striping and mirrored, even with only 2 drives in F2 layout. Okay, far is nothing but F2 layout. This runs mirroring with striped reads, giving the read performance of the RAID 0. It will give the performance of the RAID 0. Okay. Regular RAID 1 or as provided by Linux software RAID does not stripe reads but can perform read in parallel. Like this, as Thiruvengadam, as you asked, they have used the old one and they have structured according to their purpose. Okay, this is Linux MD10. This is Hadoop. Hadoop has a RAID system that generates a parity file by XORing a stripe of blocks in a single HDFS. HDFS is nothing but Hadoop distributed file system. VGFS, the parallel file system, as the VGFS is the file system manager. Okay, and has an internal striping and the comparable to file-based RAID 0. That is internal striping, and replication comparable to the file-based R10. Okay, sorry, RAID 10. Okay, options to aggregate throughput and capacity of multiple servers, and it typically based on the top of underlying RAID to make disk failure transparent. If disk failure is there, means it will be shown transparently and the actions can be taken easily. In this also they have used RAID 0 and RAID 10. As usual, is a declustered RAID. Declustered RAID scatters dual copies of data across all the disk. Two copies will be for all the disk. See here, they have mentioned possibly hundreds. So how many copies they need to take? How many topic in a storage subsystem while holding back enough spare capacity to allow for a few disks to fail. So even they will allow, even you fail also not a problem, but we have a backup. The backup will be go on taken, keep on taken. Okay. The scattering is based on the algorithms which gives the appearance of arbitrariness. Okay. So here the thing is scattered. The things are scattered and the backups are being taken frequently. When one or more disk fails, the missing copies are rebuilt into the spare capacity again arbitrarily. If it is, if for example, as I told you, if the copies are scattered, I can take an, even though if that copies fails, I can take it from some other place. Okay, everything is scattered. For example, you can take the blockchain technology. It is not centralized. It is with the different nodes, and it will be keep on building. After the completion only, it will become a product like that. Only here it is. Okay, everything is scattered and being the backup is frequently taken. Okay, because the rebuild is done from all. So rebuild is done from and to all the remaining disks. It operates much faster than the traditional rate. Reduce the overall impact on the client of the storage system. Okay, the client need not to be put their impact on the storage. Everything will be seen automatically. And what we observe from this decluster RAID means decluster. It is not in one place. It is scattered, and copies are in different place, and frequent updation are there, and it is done by using the algorithm. So taking back the information is also easy. And here some disk they are allowing the disk to fail. So they are allowing the disk to fail means it doesn't mean that they are not carrying of the data. Here, that disk failure is very minimum and they can manage it easily. Okay, and the only thing noticed here is they are not reusing any RAID concept. They are using their own RAID concept. RAID 0 or 1 or 10, they didn't use it. It is something different, scattered RAID. Is it clear, guys? Okay. As of now, RAID concept is over, and I'm sure that have you seen the RAID concept presentation, guys? Guys, whether I displayed the RAID concept presentation? Oh my God! Without displaying itself, I started the session. I'm sorry. I will show you the presentation. You can take a look on it. Okay. I thought you are viewing that, and I started the presentation. I'm sorry, guys. In the flow, I forget to open the sharing. Is it clear now?
Yes, sir.
Okay. This presentation I will share in a Google Classroom. You can view on it. Just I will scroll it down now. Okay. This is the non-standard RAID levels. There's 4 types: Linux, Hadoop, GB, BFS, and declustered RAIDs. This is some simple theoretical explanation. Actually I didn't get the exact diagram for this type of RAIDs. I'm trying to take it because it is used privately. They won't release the diagrams, right? Can you get me? They are using Linux, Hadoop, GFS, like this type. They are having separate in their data centers. It can be replicated. So standard diagram is not there. So if you collect the diagram, means you can share it with me. Okay, I tried it, but I couldn't get it. If you got the diagrams for this non-standard, because it is non-standard, they won't give the standard diagram to others to view because they can replicate it now. So this even this non-standard slides are not necessary for you. Okay, but for information sake only, I'm sharing it to you. You can know it. Okay, is it clear, guys?
Yes, sir.
Okay, that's fine. And do you have any doubts in RAID concept? Sorry?
No, sir.
No. And is it possible? Okay, okay. Is it possible for you to create your own ride or suggest your ride concept for industry? Is it possible? See, for example, I can take Shivant. Shivant, are you there?
Yes, sir.
Okay. I'm giving you the requirement that I'm just contacting you. I have such type of infrastructure. Which RAID you will be suggesting me based on the requirement? Can you give me the RAID idea? What type of RAID you can use for your industry like that? Can you give?
I would use RAID 6, sir.
Blindly you don't say Shivant, because for everything different requirement is there. Okay, if I am
Yes,
coming
sir.
up with the requirements, I don't want any security for my data, but the performance only should be high. For that, what type of RAID you will be telling? If you give the RAID 6 means it will be highly expensive. What you will do?
Yes. RAID 0 will be efficient in that case, sir.
Yeah, like that only. For each and every requirement you need to analyze, and after that you should provide the RAID. Okay, is it clear?
Yes, sir. Yes, sir.
And it is not necessary that you should use only one RAID. You can combine it, because
Yes, sir.
everything is standard now. See, R10 it is hybrid. They have combined 1 and 0 from the, if 0 and 1 is one type and 1 and 0 is one type, right?
Yes,
And
sir.
as we saw in the non-standard types, they have used R0, R1 and 0, and three companies have reused the same type of techniques in different way. That can be done. That you can also do. That type of structure you can also suggest. Okay. And to
Okay, sir.
make sure that don't use 2, 3 and 4. 2, 3 and 4 rates are just for the information sake I gave you. Those three are failure rates. Okay. It's no use of using that. There is no meaning. Okay.
Okay, sir.
Is it clear? And I would like to ask some question to the students, and after that we can leave. Um, Randomly I will call someone, because this question is not to test you, to test myself whether I have delivered the content correctly or not. Okay? And Vimal Raj, are you there? Vimal Raj. Vimal Raj? Guys, please respond. The course is going to go over, and this time also you are not speaking, means when you will speak. Sri Vishnu? Sri Vishnu, are you there? Thiruvengadam has asked that where we can use rate 0 with 8, 5 or 6. Okay, Thiruvengadam, what you have messaged? I couldn't get you clearly. Oh, is it clear? Okay, okay. Yeah. Yeah. You can combine each and as I told you, to achieve specific goal, you can use each RAID of different combination. That you have that independence. Yeah. Yeah, you can, based on the requirement you can use it. What requirement you have now? To improve the security? Maximum redundancy. So what you are going to combine now? RAID 6 with 1, and it is actually RAID 6 is 1. Theoretically you can do it, but how to say, as I showed in the uh, presentation, RAID 6 is not used supported currently by any RAID implementers. RAID 6, why it is not currently supported means, in each and every stripes we are taking 2 parity. In some cases that 2 parity is waste of memory. Can you get me? Already 1 parity. Yeah, already you are having the 1 parity, so that is enough. Okay, that is more than enough. And 2 parity is wastage of cost and resources. So for that, implementation difficulties also you will be having, because if you are having 4 space for your disk means 2 space you are giving for the parity means, and 2 space only for your disk means it is resource wastage. And if you are having 4 space for disk, if you are providing 1 space for parity and 3 space for disk means, that is reasonable. Am I clear? Okay. And Sophia. Sophia.
Yes, sir.
Okay, Sophia, can you tell me? Wow, what is RAID 1? What happens in RAID 1?
Even mirroring taken place, sir.
What is the drawback of RAID 1?
I'm not remember, sir.
Sorry? Okay, drawback is nothing but it's a double storage cost. Okay, in that RAID 1, mirroring will be happening. If you are having 4 disk means you need to invest for 8 disk. At that time, double storage cost will be there. That is considered as the drawback. Okay. Okay, that's when it's already 10:50. Guys, are you clear with the concept? Thank you, Sophia.
Yes, sir.
Okay, do you have any doubts in it? If you have any doubts, means please ask me. I will clear. And for the exam, continuous assessment exam, till today afternoon, what you're going to see in your class, that is the portion, okay, from third and fourth module. And all the best for your exam. Do it well, and come after. Now it is 10, 11. You come at 11:25. Is it okay? Exactly after half an hour, you come at 11:25. Professor Shiva Shankar will take some concepts to you from this file management module. Okay, and thank you. And is it clear, guys, whether the session was good? Because it is theoretically whether the session was good and informative. Did you gain something?
Yes, sir. Yes, sir.
Okay. Okay, guys. Thank you. Come back after half an hour. Yeah.
Thank you, sir.
Thank you. Yeah. Guys, now I will play the video. It is for just 5 minutes. You can see the video. It is the complete video representation of the RAID concept. Only the RAID which is effective will be presented in that RAID 0, 1, 5 and 10 will be explained in that work, and other things are not necessary. You can see this video, and if you have any doubts you can ask me. Ask your friends to join. If they miss the video will be available in the Google Classroom. You can check it and see the video again. Now I will play the video for you.
storage is a very important part of fault tolerance. If something were to happen to a company's data, such as a disk failure that results in data loss, then that could have a serious impact on how the company performs. That's why we need to make sure that if a disk does fail, that no data loss would occur. And one of the best ways to prevent data loss is RAID. RAID stands for Redundant Array of Independent Disks. In a RAID setup, the data is copied on multiple disks, so that in the event of a disk failure, no data would be lost. Now there are 4 common types of RAID. There is RAID 0, RAID 1, RAID 5, and RAID 10. Now RAID 0 is not fault tolerant. In fact, RAID 0 shouldn't even be called RAID, because not only does it not provide fault tolerance, it actually increases the chance for data loss. Because in a RAID 0, the data is not duplicated, but it's actually spread or striped across 2 separate disks. So if just one of these disks fails, or if you decide to destroy it yourself with a hammer, then all the data would be lost. So the only reason why you would want to use RAID 0 is speed, because when you have 2 disk controllers working instead of 1, then accessing data is much faster. Now RAID 1 is fault tolerant. In a RAID 1 setup, the data is copied on more than one disk. So disk 2 would have the exact same copy of the data as disk 1. So in the event of a single disk failure, such as getting destroyed by a laser beam, then no data loss would happen because the other disk would have a duplicate copy. Next, we'll talk about RAID 5. In order to use RAID 5, you need to have 3 or more disks. RAID 5 is probably the most common setup that is used because it's fast and it can store a large amount of data. So in a RAID 5 setup, data is not duplicated, but it's striped or spread across multiple disks. And in addition to the data, there is another very important piece of information that is being evenly spread across all the disks. And this information is called parity. And parity is used to rebuild the data in the event of a disk failure. But there is a downside to RAID 5, because since the equivalent of an entire disk is used to store parity, it reduces the collective amount of data that can be stored in this array. So for example, if all 4 of these disks were 1 terabyte each, that totals 4 terabytes. But in a RAID 5 setup, the total amount that would be used for data storage would be 3 terabytes, because the equivalent of 1 entire disk would be used to store parity. And finally, there is RAID 10. And RAID 10 is basically what the name says. It's combining RAID 1 and RAID 0 together. And you need to use a minimum of 4 disks. So in a RAID 10 setup, a set of 2 disks are mirrored using a RAID 1 setup. Then both sets of the 2 disks are striped using RAID 0. So RAID 10 benefits from the fault tolerance of RAID 1 and the speed of RAID 0. But the downside in a RAID 10 is that you can only use 50% of the capacity for data storage. So if you are using 4 disks in a RAID 10 setup, you can only use 2 of them for actual storage.
Guys, is the video explained clearly? Is it okay? Okay. Okay, those who have missed this video, you can find the video link in the Google Classroom materials. I have given the presentation along with this video. You can go and view it. Now I will hand over the session to Professor Shivashankar. And bye-bye. Do the exams well. Bye.
Thank you.
Good morning, students. Am I audible?
Yes, sir. Yes, sir.
Okay. Now we'll see some disk scheduling algorithms here. So, what happened in CPU scheduling? Before getting into disk scheduling, I need to give some quick recap on CPU scheduling. What happened there? We'll be having a CPU, and our requests will be formed in the form of processes, different processes. E2, E3, and those processes will wait for their turn to get into CPU, right? And we have a scheduler there. With the help of that scheduler, this process gets into CPU, right? This is what happened in CPU scheduling, right? Guys, do you remember this?
Yes, sir. Yes, sir.
Okay. Uh, from where this process are being taken, from where this records are being taken, these files, from where these files are being taken, do you have any idea? From where these files are taken? This is our RAM.
Secondary.
Thank you. We have another person called as an hard disk drive. That is our secondary memory. Have you guys ever got a chance to see your this thing, dismantle the hard disk? Have you ever repaired your hard disk today? Anyone? What are the
Yes.
things that you saw inside your hard disk?
CD.
Like how it will been like how many layers can you able to see inside your hard disk? Yes, there is a person called plotter, and this whole thing looks like a compact CD disk. So here you will be having some different sectors here, like these are all the sectors. This whole hard disk, when you get inside, it will looks like a bunch of CD. Guys, have you ever written any data on your CD? CD? Have you guys ever written any files on your CD? Like the whole process will in that what you used to do? Obviously, at the end of the day, we used to do read and write operations, right? In our files. So these things has to be come for a RAM, right? After which only it can able to come for the CPU. So you got an idea what is happening in the hard disk, right? We have another person called Am. Am will be there. As you see in the movies, in the old movies, there will be a pointer kind of this thing, right? That big CD will be there. For hearing in a song, they will be placing some this thing. Have you ever seen this? There will be an arm that some pen tip kind of a thing will be there. We'll call it as an arm. So how our data will be written here? Do you have any idea? There will be some different sectors, as I said. Those sectors will be having our data. Each sectors will be there in our internal hard disk. This sectors will be having some data. So far it's okay, right? What is happening in this thing? In order to find our data from our hard disk, here we have an algorithm. That algorithm is called as a disk scheduling algorithm. Here we'll see about what is happening after this. Suppose in case we have a 3 process. See here, process A wants to read tracks of suppose in case I will take 4 and 5, and the process B is there. And it wants to read the tracks of say for example 7 and 8, and we have another process called process C. And it wants to reach perform some read operation on track number 8 and 4. So what will happen? We have a person called OS. OS has to read those tracks. With the help of whom we can able to achieve this? Any idea on this? Now we have a process request of 4, 5, and it was requesting these tracks to perform their executions. What will happen? It will seek the help from OS, right? Guys, are you following it?
Yes, sir. Yes, sir.
Consider this was a disk. So to fetch data from our hard disk, we need to perform some. On what basis we have to perform this? Different process here. If you look into this picture, you will get an idea about what is happening here. Different process wants to store their data in our disk, or different process wants to read data from the disk. Suppose a multiple process come into that case. In that case, operating system will have to decide which process request needs to be fulfilled first, or we need some scheduler here. With the help of some scheduler, we can able to fulfill every process request that are been present in our hard disk, so that the expected data can be transformed to the CPU or RAM. So is that clear? Can we move on to the disk scheduling algorithm? With the help of operating system, to schedule I/O requests arriving for the disk the disk scheduling has been happening. It is also called as an I/O scheduling because input and output operations are being performed. So what we'll do when you are opening a file? Obviously, we are read and write operation can be performed in our document, right? At the end of the day, where you are going to store your files? Do you have any idea? since we can't store our data in RAM itself, where we are going to store our data? Guys, respond.
Secondary memory.
So what are the operations that you perform in your Word document, or if you are watching in a movie on your laptop, after at the end of the movie, where it will go? Since after finishing your movie, where it will go? It will move on to the original position, right? Say for example, if you are storing that movie in your hard disk, it will whenever you are watching the movie, it will be moved on to the RAM. Since RAM is a volatile memory, we can't store their data at RAM itself, so it has to come back to the original position, that is in our secondary memory. So whenever when the required data is being needed, it has to move from front and back. So that is, if the user is requesting some data, in our case I am taking a movie, it has to be moved from the hard disk to RAM, and once the movie has been getting bored, or it has been finished, so it will come back to the original position. So in order to perform that expected data that are present in a hard disk, here we are going to see some scheduling algorithms, like how the data are being read from our hard disk, and with help of some scheduling algorithms, we are going to see how this hard disk are being accessed. So are you guys clear about this? Like if you are having a CD with you, you can see that your backend of your CD, that is compact disk. If you are getting a chance to see that, once your files are being written your CD, there will be different layers will be, right? Have you guys seen it? Backend of your CD. Have you guys seen that?
Yes, sir.
How it will be? The written the full CD will be like up to this it will be fulfilled, right? If you are burning in a CD, that there will be in a different sectors. Like same likewise, our hard disk will be containing a bunch of CD. In that we will be having in a sectors. In sectors we will be storing our data. In order to fetch our data from this sectors to get into our main memory or CPU, here we need someone's help, right? With the help of some algorithms, we can able to fetch those data from our hard disk. So that's what we are going to see from our disk scheduling. Guys, is this clear?
Yes, sir.
So what's the scenario here? Now we are going to how the data are being stored in, how the data are being moved front and back from our hard disk. So that front and back operations are, we can also call it as read or write operations. So what's happening in our this thing, disk scheduling? Can someone tell me? Guys, before getting to this disk scheduling algorithm, I'd like to know about that, some terminologies involved here. So, what is seek time? Can someone tell me in a normal this thing? Suppose you are in a queue, that is a queue size of 10, 0 to 10, and you have a server here. And you are in position of 7, and every person can be served at every interval time of 1 minute. Then what's your seek time there? Can someone tell me? And you are in position of 7, and every person can be served at the interval of 1 minute from the server. So what's the seek time here? Guys, you got my question?
Again, sir, again. Sorry?
Every person can be served at the time of interval time of 1 minute, and you are in position of 7. So what's your seek time there?
6, sir.
6 or 7? Sorry, 1 to 10. I'll take it as 1. So if you are in position, the queue size is of 1 to 10 and you are in position of 7, then in that case your seek time will be 7 minutes, right?
Yes, sir.
Same likewise, what is happening in seek time is the time required to move the disk arm to the required task. That is, if your arm has been at a random position, it can be in not in our, it can be in any position that is placed in our sectors. It can move from front and back. It's the main characteristics. It's been like this. Arm is nothing but a nib in your pen. Same likewise, we'll be having some arm in our hard disk. That arm will be at a random position. Say for example, if it is in a position of 53 and you are requiring to access an sector of 70. So in that case, what's the seek time? From 52 to 70, what's the seek time now?
7. 7.
17, right? So this is what is all about seek time. The time required to move the disk arm to the required task. That is what we call it as seek time. And the rotational delay, we'll call rotational delay. What we call rotational delay, time required to rotate the disk to the required task. Guys, if you are following it, if you find it difficult, you tell me, or otherwise I'll tell it one more time. Is that okay for you? Time required to rotate the disk to the required sector. That's what we will call it as a rotational delay. Guys, are you following it?
Yes, sir. Yes, sir.
What is time delay? Can someone tell me? The time required to rotate the required task. So in case if you have a disk like this, the time required to rotate the disk. So if you are in a position of 55 or 50 and the disk can randomly move in this direction or in this direction, this rotational delay will be able to find that position of the expected. Say for example, you have to reach in sector number 100. So what's the rotational delay here? Can someone tell me?
50.
50 is our rotational delay, right? Since the initial arm position is like at 50, so the rotational delay and seek time will be, if you are looking into this, it will be following the same thing. So what is the data transfer time? Can someone tell me? Do you have any idea on data transfer time? Say for example, your friend is giving some files on your pen drive, and whenever you are inserting and copying your data from your pen drive, suddenly all of a sudden you will be data transfer time will be estimated in your this thing, right? That console. The console will get popped up and you will get to know about the data transfer time, right?
Sorry, sir.
So that's what we'll call it as a data transfer time from the with respect to the hard disk. So time required to perform some read and write operation. That's what we'll call it as read and write our data from our from the disk. I told you an example with respect to pen drive, but here the what's mean by data transfer in with respect to disk means time required to read and write data from our disk. So if you are not able to catch this concept, I will explain it with some few examples. The first, there are some few algorithms with related to the scheduling algorithms. We'll see one by one. First one we are going to see is Sstf, that is shortest seek time first. Guys, are you following it?
Yes, sir.
Shortest seek time first. We'll see this algorithm with example. I have a disk here. My disk contains tracks of 200 tracks, and it has like 100 to 99. Inside the tracks, I have 0 to 199 tracks, and my request queue is something like this. My requested queue contains track number of 93, 176, 42, 148, 27, 14, 180. And finally, we came to know that our current position of our arm. So, what is arm? Can someone tell me what is arm? Current position, or we'll call it as arm. What is head? That's position is 55. What is mean by head or arm here? Can someone tell me?
The position at the sector description.
Okay. What the Sstf tells is shortest seek time. In Sstf, the request having shortest seek time are executed first. So we'll see this how it works here. Consider this line as an sector queue, and currently we are in position of 55, and our request is like something like 93, 176, 140, 42, 148, 27, 14, and 180. What Sstf tells us, the seek time of every request is calculated in advance in queue, and we are going to schedule according to that seek time. As a result, the request near the disk arm will get executed first. So now I am in 55. Where I can go here? What Sstf tells, those who are in the list with the shortest seek time will be taken care of it. Will be executed. So there is no meaning of going to 93. There is I can't visit 176 sector also. So because I am currently in a 55 position, so can I go to 42? Since I have only 13 sectors, I have to move only 13 sectors. If I am visiting 42, can I go to 42 here?
Yes, sir. One doubt, sir. After 40 to 148, sir.
Yeah. Sorry.
Okay.
So I'm moving from current head to 42. So I can't go to 148 also. Since my current head position moved to 42, where I can go? I can go to 27, right? So I'm moving my head to, I'm fulfilling the request of a 27th sector to be loaded. And where I can go now? I can move to, I can visit to 14th vector also, right? 14th sector will be coming here. So once I reach the end position, now I can change my direction. That is, I have to visit sector number 93 also. So if we have to check our request queue here, before 93, do you have to visit any other sectors here? Can someone tell me? Will we have to go for any other sector now? We don't have any persons to visit, right? We have fulfilled all the request queue here, right?
Yes, sir.
So can we change the direction to the opposite one?
Yes, sir.
So I'm moving the direction since I don't have anyone to visit in that opposite direction. So I'm going to visit the 93 sector. 93 will be coming somewhere here. If I'm moving the direction here, I can visit. So after 93, can I go to 176? Before visiting 176, I can able to load sector number 140, 148. I can visit, right? Guys, are you following it?
Yes, sir. Yes, sir.
So after 148, anyone is there to visit? Where is this? So whose request I can fulfill here? Which sector I can visit? 176. So we have visited all the sectors here, right? We have missed out anyone?
180, sir. 180.
180. Oh yeah. After 176, we can visit 176. So we have visited all the sectors, right? So how to calculate our seek time here? With the help of that formula. What that formula says? Can I change the page? Are you guys copying it, or should I have to? Can I change the page?
7 seconds.
Sorry?
Okay, sir. Okay, sir. Can change.
Can I change the page? So how to calculate our total access time? Change the page. Can someone tell me what first we have visited our this thing, right? Let's change the page. So here itself I'll do. In order to find our total access time with respect to our SSTF, what's that formula? What the formula says? Seek time plus rotational delay plus data transfer time, right? Here, at first we are in position of 55. See here, up to which end we are going here? We have started from the position of 55. In one direction you calculate. We have gone up to 14th sector, right? 14.
Yes, sir.
So 55 minus 14. So from there we have changed our direction, right? So up to which direction we have went? Can someone tell me which sector we have went?
180, sir.
So 180 minus, you calculate the current position
14.
of 14. So total how much? You have a calculator with you. So 15 minus 14. So in total we'll be getting like 207 tracks. If I'm not wrong, it will be like a 207 tracks. So for fulfilling the request queue contents of these numbers, we have moved from we have moved our head position like a 207 tracks are being moved from front and back. This is what happens in Sstf with respect to disk scheduling algorithm. Guys, you got the point what I told here?
Yes,
Sir,
sir.
in this case, rotational delay is 41, right, sir?
Sorry?
In this case, rotational delay is 41, right, sir? Because from 14 again we need to come to 55, which is the rotational delay. Am I right,
Yeah.
sir?
Yeah. From
Thank you.
55, we have gone for the sector number 14. So we are taking that direction, and we are taking the other direction as well also. From the current position, we have taken the shortest seek time first, and that is in our case we have visited the 14th sector. Up to 14th sector, we are getting the one side direction plus, and we are going for the opposite direction. You got the point? From guys, are you there?
Yes, sir, got it, sir.
Yeah, okay. Can I change the pitch? Yeah, tell me. No, while you are going, we have to another thing, right? Shortest seek time. From 14, we can visit for 93, right? Instead of going for 180. What our algorithm says? Shortest seek time, right? From 14 to 93, we have a shorter distance, right? Instead of visiting 180. You got the point? See the distance from 14. Sorry? Ah. Hmm. So this algorithm says they are not. Sorry. Yeah. So this algorithm says that our position current edges and like in a 55. They have not mentioned any clockwise or anti-clockwise direction. So according to that, we have to perform our operations here. Instead of thinking about that direction, sorry, clockwise or anti-clockwise direction, with respect to shorter seek time, we have to perform here. Instead of reaching the end of this track, it's a meaningless, right? While you are going itself, you can visit these places like these sectors itself. You got the point? Why we have to? While you are going itself, you can take that. You can take those data points, right? Instead of going to that last and then when you are going to fulfill that. When you are going to that end of that track, that time itself you can able to fulfill that other sectors also, right? No, we are not going to zero and all. Okay. No, in this algorithm, it has been designed in such a way that it has to give the request whoever has been near to the shortest from the current head, those who are in shortest seek time, those requests can be fulfilled. That's what the Sstf tells. So when you are moving on to that next algorithm, there that scan and some other C-scan algorithms are there. There that arm position will be moved up to the end of that tracks. So you got the point? Trivandrum, are you there? You got the point? Can we move on to the other algorithm? That is scan. Sorry? Okay. Now we will see how scan works for this sequence. What scan says is, the arm moves in one direction only, satisfying all outstanding requests until there is no more request in that direction. Can someone tell me that the previous request queue our tracks are in like 1 to 99, and our request queue
93,
93,
176,
176,
42,
42, fine, 148, 148,
27,
27, 40, and 180. Current position, Edison, 55, right? Okay, we'll see how scan works for this sequence. That if the arm is in like a 55, here the scan moves in one direction only until it's fulfilling all the outstanding requests, until there are no more requests in that direction. So here what is going to happen is service direction is then reversed until if you are I'll write 102, 199. So whose request we can able to fulfill? If I am going to 42, sorry, my current head is in like 955. So I am going to move in that greater number side. So what will happen here? 93. So while I'm going for 93 sector, what all the other data points are there? Other sectors are there. 176, 149, 180. Whose sector I can visit first? After 93, I can go for my 148. Okay. Who's after that 148? I can go to 176. So what's after 176? Now 180. What scan says is, if your head position is in from the current position, you move to the one direction until all the outstanding requests have been satisfied. Here in our case, we have fulfilled, we have visited all the sectors here. Here also we are not going to visit the end point. So we have visited all the sectors here, right? In our queue, that are present in our queue.
Yes, sir.
Now at that end point, that is in our 180 the track, we are going to change our position. That is, we don't have to visit anyone. So since all sectors are being visited, we are changing our direction. So if I am changing my direction from 180 to where I have to go, which sector I can reach here? I can go to 42, right? So which after 42, who can be visited here? 27, right? So after 27, which sector I can visit? 14, right?
Yes, sir.
So at first, or sorry, what will happen in scan? I forgot to tell. In scan, what will happen, right? After finishing our end request, that is 180. Someone asked, we have visited 180, right? After visiting 180, if you have a request in our queue, that is request in sectors that are to be visited after our endpoint. That is, in our case, we are taking 180. Even if you don't have any more vectors or sectors that has to be visited in your current direction, until we have to visit all that sectors. That is, I have to move from 180 to end point of our track. In that direction. So at first my position is in 55, while I turned my direction towards that from the request queue. I have visited 93, 148, 176, 180. My tracks have been ended. Sorry, my request queues requests are been ended up to 180, even though after my requested sectors have been fulfilled there itself. The scan says once you have moved your direction from a particular point from the current position, you have to visit the end point of the tracks. So from 180, we are we are visiting 19 tracks. Trivangaram, you got the point? Here, this is what happens in scan algorithm. So here I am turning my head position. So from 199, I am changing my position to up to 14. Since I have a request up to 14, so then and there we are stopping there itself. We don't have to visit in 0th point. Since we have already visited end point in one direction, we don't have to go to the opposite direction. Since my head position has been stopping there itself from a request queue. So what's the condition here in scan? If you are changing your direction, if you are changing your current head position from one direction, and the requests have been satisfied in that direction, you have to move to up to the end point that are present in our tracks. So in that case, what's the disadvantage here? If my track position has been, my seeking request queue has been ending up to 176, what will happen? You have to unwantedly visit up to the end point. That's a major disadvantage. But when you are visiting in that opposite direction, what you have to do? You can stop wherever the request queue is being ended. That is, in our case, we are taking 14. Guys, have you got the point? How the scan is working?
Yes, sir.
So what's the seek time here?
$199.
199 minus
55.
199 minus 55 plus
199 minus 50.
we have changed our direction from opposite, that is 199 up to
40.
So what's the tracks that you have visited so far to fulfill our request? Can someone tell me? 199 minus 55 plus
329.
we have visited 329 tracks. Guys, you got the point? How the scheduling algorithms works for scan and what's the other thing? You have any doubts on this? Guys, you got the concepts clear?
Sir, this is data transfer time only, right, sir?
Yeah, the final total access time has been calculated here. With the
Sir,
help of
for
that
peak
formula I
time,
told.
should we reduce the rotational delay, sir?
Sorry?
If you want to find the sum of, all the seek times, should we reduce rotational delay, sir? I mean, repetition of the needle.
The rotational delay says that the time required to rotate the disk to the required sector from our 55 to 93. What's this thing? Rotational delay. As I said previously, you are in a position of 55 and you have to reach a position of 670. What's the rotational delay there? 15, right?
Yes, sir.
So in order to calculate a rotational delay and this thing, total access time, here we are having finally we have a total access time. To calculate the total access time, I told you that we have to take care of seek time plus that rotational. Shivant, you can mute yourself. That the total access time can be like calculated with help of that seek time plus data transfer time plus that rotational delay. What is rotational? Sorry, data transfer time, time required to read or write operations that are to be performed within that from that sector. Guys, you got the point?
Yes, sir. Yes, sir.
You guys have any doubts on this from the disk scheduling algorithm? Gayatri, are you there? Gayatri? Gayatri? Gayatri, yes. 9036, Gayatri. Arshini, are you there? Arshini? Arshini?
Yes, sir.
You got the concepts clear?
Yes, sir. I can understand, sir. I'll try one or two sums, sir. I'll become fully clear, sir. I can understand, sir.
Okay. What about others? Jayasurya, are you there? Jayasurya? Kadiroli? Kadiroli? So what about others? Madhavan, are you there? Madhavan? Madhavan?
Sir, I have a doubt, sir.
Yeah, tell me.
Sir, suppose we are starting from 55 and we are going to 42. Then we switch back to 93. Then only no, sir, we'll calculate rotational delay as difference between them. If directly we are going in one direction, there is no rotational delay, no, sir.
Rotational delay says that time required to rotate the disk. You are clear about that, right?
Yes.
We are from the current position instead of sorry. Okay, what will be the this thing? If you are moving our direction from 45 to 55 to 42, then in that case we will be 13.
13.
From there 42 to 27. What will be the rotational delay here?
So this difference is the seek time also.
Seek time and rotational delay, it deals with the
Is it
same
all?
thing.
Okay.
Seek time is, as I said in that previous example, if you are in a queue that consists of 10 members, that if you are in a position of 7 or 6, that every person can be served in that in time interval period of 1 minute, then what's that this thing? Service time in that, then you will be getting service at the time of 6.
Yes, sir.
You got the point?
Yes, sir. Somewhat clear.
Okay.
If I look at examples, I'll be clear, sir.
Okay, I will upload the materials with respect to the disk scheduling. You guys go through that. If you have any doubts on this, you just come again and you can ask doubts on this. Is that okay for you guys? Can we wind up this session?
Yes, sir.